titles. Oh, thank you, Riley. Everybody will be yeah, represented on this at the end of the session. So at the end, you'll have a little slide of experts to take with you. Okay. So as a just sort of orienting us to how the session is going to go. So we're going to have a little bit of a sort of a brief intro, a sort of ground setting, context setting intro by Sonia Ahmed, my colleague and co-chair for this session, thinking about sort of setting the stage for the land energy nexus. Then I'll give a little bit of a brief history and current snapshot of the land energy nexus and what that maybe some ways that that looks like within our global land program. And then we're going to have this sort of highlights of just a variety of really amazing research from within the global land program community, members that have been researching and doing really awesome work, across geographies and across technologies and across the landscape of the land energy nexus. So we'll hear little snapshots from all of them. And then we'll kind of come together at the end and think about, some of the pathways forward for continuing engagement, continuing to source ways to share with each other and collaboratively work together moving forward, and some opportunities, that we're seeing, from our perspective within sort of GLP, yeah, different ways that we might be able to connect and bring all of our expertise forward in really exciting ways. So with that, Sonia, I would love to turn to you for a little intro.
All right, thank you so much, Bar, for inviting me to co-facilitate this panel. I'm really excited for the next 50 minutes or so. And just a very quick introduction here to who I am. Bar, I was realizing we've been collaborating and working together for about 10 years. And so my area of study, and this is back from our PhD days at the University of Vermont, was energy system transitions. I focused on just transformations, the water energy food nexus, decolonization, which has really been at the forefront of some of my more recent work, which I'll talk about in just a moment, and geospatial data science, which I'd had a prior decade or so of experience in at a data center at Columbia University. And so now I lead a program, study abroad program at the School for International Training that focuses on climate change, the politics of land, water, and energy justice, where we take students through the course of one semester to, we start in the United States. We'll be starting in Miami for 10 days this upcoming fall. We used to start in San Francisco. And then we travel to Ecuador, Morocco, and Nepal. And so this experience is really focused on learning from communities. And we focus on case studies that center local struggles, that link local issues to global networks and governance and supply chains. And some of my kind of long-standing research, both from my formal training and now as a practitioner and scholar, is in how entangled fossil fuel power is with global governance, especially in major extractive states. And I would say that the U.S. is probably the world's leading petrostate in our current configuration. And then how this transformation, or what we hope is a transformation, is intricately connected with the water, energy, food, and I would argue also the material nexus. And so as Bar and I were, next slide, Bar, if that's okay. The things that Bar and I were talking about as we were formulating how this would go, and things that have been sort of front of mind for me, that we checked in about recently, was that decarbonization, that the energy transition could reproduce the inequities of the fossil fuel paradigm in other spaces, this idea of green sacrifice zones that we're seeing, and that there's a different relationship of renewable energy than fossil fuels on and with the landscape, but that doesn't delegitimize or defocus just how the urgency and gravity of the concerns about what that the sacrifice zones that are involved in this transition as well. That there's no one right answer for energy alternatives, that they're often driven by local energy endowments and constraints. And then this idea that I think maybe matters a lot here, that not just if we frame it as community participation as being essential, but that the decision making should be driven by local communities and what that means within these very different and sometimes compromised contexts within national and international framings. And then this kind of maybe question that's motivating us a little bit more in an overarching way is what analytical tools and governance processes are needed to support just energy transformations. So thank you, Barb, for the time to be able to set the stage. And
Yeah.
yeah, look forward to turning it over to our wonderful panelists here.
Yeah, great. Thanks, Sonia. And yeah, and as Sonia was sort of summarizing and we were thinking about these sort of key themes, I think what was coming up for me is so many of our presenters that you're going to hear from really grapple with these, questions and challenges and think about, ways to sort of highlight where community participation is important, where, what types of analytical tools are available. And you'll actually see some of these tools during these sessions and thinking about the governance processes. So it's definitely, yeah, it's really exciting to see so much of this work really represented around GLP. So I wanted to give just a little bit context setting of, when we think about, renewable energy and sort of non-renewable energy, often we see and hear, and, the narratives that are out there are often graphics sort of like this, where it's, often presented a little bit as this sort of binary or, on the one hand, a beautiful, flourishing renewable energy world. And whereas on the other hand, a very polluted, very extractive, non-renewable energy world. And of course, as land system scientists, I think it's no surprise that within our community, there's people that are really grappling with the land systems questions, both in terms of the environmental impacts and also the social impacts of these technologies and these different ways of producing and using and consuming energy, um, and that this picture is not is actually much more nuanced than is shown here, in that even within wind power, within solar power, within hydropower, there's definite land implications both for like environmental and social impacts of these technologies, and that's really important to underscore. And of course, not just along, as we think about just the technologies themselves, but also along the sort of life cycle analysis of like, well, where are the raw materials and, the extraction for all of these energy systems and new energy technologies, and like what are the land implications for that, and the environmental and social justice implications for the extraction. What about for the design and the production? And maybe, also the usage, as well as the disposal and recycling. And I'll just make a little asterisk here on the usage piece, because I think this is an important conversation that's gaining a lot of traction in the news recently, is just in terms of AI. So I'll give a preface and say both of these graphics that I found are how I used to do this was I used to search for Google images on graphics that, words that I was trying to find graphics for. And I would use Creative Commons licensing and say like, oh, usually you'd find some little drawing that a scientist had made or something that could summarize what you're doing really well. But in both of these cases, and I think increasingly, you search graphics on the internet and now it's just a bunch of AI generated images. And so I could hardly find anything that wasn't AI generated when I was just looking for, Google, like who's doing pictures of life cycle analysis. It's like, the top. Anyway, all to say with that asterisk of energy usage is that that's such an important part of the question. Is like also what is our energy being used for, and what are the land implications of those sort of usages. Anyway, just a little plug and a admittance that yeah, AI. But across GLP, so my sort of snapshot here is that we have just a wealth, I think, of expertise generally. I mean, this is like, the culminating session of the week of land system science. We have over 3,000, land system scientists, members of the Global Land Program who are just doing phenomenal work on all sorts of land related topics. For land energy challenges, in particular, we actually do have almost 700 members that have sort of highlighted this as one of their areas of expertise within the Global Land Program. And that might be, in fact, is probably many of you in the audience. So we do have just a great geographical spread of GLP members who study energy and have energy expertise around the world. And when we did a community survey recently, this was last year, right after the Open Science meeting, we asked our community, what are some of the main big tensions, main challenges that you're seeing in the land systems field? And I'm just putting up a small snapshot of some of those answers that we got from our members. And you can see, across geographies, we have sort of these deep challenges that GLP members are saying they're grappling with, related to illegal mining, related to the nexus of land tenure and energy systems, related to land grabbing and carbon markets and sort of corporate land ownership and greenwashing, looking at sort of a critical look at the trade-offs of renewable energies, across the board. So we really do have, like I said, this sort of depth of I think expertise and interest, and a lot of people working on these sorts of challenges in just a wide variety of geographies, across landscapes, across different types of energy technologies, and looking at this at different scales. So what's really exciting is that now you guys get to hear from GLP researchers who are doing this work across scales. So we have a great lineup. Like I was saying, I wish we could do a 5-hour long session and you could have an hour-long talk and discussion with each of these researchers. It's, just such a breadth of expertise here. But what we're going to do is, just have them all give a little highlight of their work. And alongside this, as I already mentioned in the intro, is, Riley's been posting in the chat our link to this mural board or Miro board. If you're not familiar with them, it's just a sort of a gathering board where you can type in, there's sticky notes, you can kind of type in various, we have places to type in things like citations or organizations to watch, or if you have, ideas for papers or experts to connect with. We have sections for the research area, the themes you think might be of interest. And then we have this little GLP map at the bottom where you yourself can drag over a sticky note for projects that you're working on around, across different geographies, just so that we can start to get a sense of all of your expertise. And so please feel free to engage with that, during this presentation, but especially after. We'll have it open, open for another week or so after the session, and we'll follow up with that. But just so that, we know that all of these amazing talks are going to bring up so many pieces of you might connect themes with work that you're doing. And we really want to make this a collaborative space. And we'll have a little moment at the end to talk about how we can take this conversation forward and collaborate better together across GLP. But without further ado, I really would love to turn this over to Monica. I think will be our first presenter. So Monica, if you are ready, and you can tell me when to move forward.
It's very short presentation mine. I made a very short presentation. First, small presentation of me. I'm Monica Bárcenas. I'm currently third year PhD researcher at Freie Universität in Berlin. And but I'm originally from Mexico. So I been working a lot on understanding the solar energy transition, the photovoltaic energy transition in Mexico. Okay, well, this is my research. The start of my research was about how we understand the energy transition in Mexico that started in 2015 officially, but it had a dramatic stop in 2018. So there was this 3-year laboratory that gave us a really good way to understand how private companies enter the Mexican energy transition, yeah, how they went into Mexico. So to understand this, I decided to do, I'm a geographer, so I decided to do a geographical analysis to first understand what was there before the installation of the solar parks, specifically solar parks that are in rural areas in Mexico, because there are a couple of examples that are in industrial areas or within cities, and those I didn't take into account because that's a very direct use of that energy. So these were specifically solar parks that were built to produce energy to go into the grid. So first understand what was there before, and for most of the solar parks installed in this time frame, they were located in land that previously was agricultural land and shrubland. With that, I decided to do a statistical model, a generalized linear model, to understand the characteristics that help me see what the energy companies and the government decided where to put these parks, with a lot of variables, social, economical, and environmental variables. And with this, I could have a lot of interesting results that told me that specifically for the installation of this cohort of solar parks, they didn't really deforested it. They previously used land, and that the solar parks prefer to be not so close to cities, but close to main roads, close to the electrical grid, and with a medium size of 3.5 kilometers. But there are some really big ones and there's some really small ones, square kilometers, sorry. And finally, to add a bit of cultural and social significance to my study, I did a agrobiodiversity index. So I combined the varieties of agave, that's where the tequila comes from, and varieties of maize. That's the main food in Mexico. So with this combination of characteristics, I built a biodiversity index that gave me the distribution of areas that could make a problem with the expansion of the solar parks. I forgot to mention that the generalized linear model gave me a map that had the same characteristics of the parks that were already installed. So areas where the expansion of solar parks could potentially be. So next slide, please. So finally, adding all this data, I combined the information and I got areas where you can see that there's potential for solar park installation, and the biodiversity index that gives areas where there's really high biodiversity index of these two agro biodiverse species, and areas where the solar parks could expand. And those are trouble areas where the solar parks, now that we are retaking the energy transition in Mexico, could affect the genetic distribution and the cultural significance and the economic significance to rural communities, indigenous communities, and biodiversity in general. And that's it.
Yeah, thank you, Monica. Um, we're just gonna, I think if it's okay with everybody, I'm gonna just keep us going with the sort of the overview of the highlights, and then feel free to type in the chat if you have any questions as we go, and we'll kind of have a little question session at the end. But with that, yeah, great, yeah, great sort of overview of the solar panels in Mexico, and now we're gonna think about how this looks like in Brazil. So Amanda, if you're ready.
Hi, Lindsay, thank you. Monica, congratulations. Very interesting work. And I'd like to present you a Brazilian case study. It was part of a Brindisi Values project between Global North and Global South, trying to understand how government they were struggling for biodiversity conservation in very important hotspots of biodiversity. And in Brazil, when we arrived in this protected area, here in the middle, the heart of Bahia state, in Brazil, if you can see my point, it's a semi-arid land, and it was the last refuge of jaguars in semi-arid land. So it was a very important biodiversity hotspots. And at the same time that the government was trying to protect all this area across this big lake that you can see here, and in this green, they create a national park. And in red here, it was a less protected area. What happened? All this should be a conservation unity, protected area. But the interesting of economic renewable energy didn't let government create this all big protected area, because they begin to install the aeolic towers, thousand and thousand and thousand and thousand and thousand. And how you can see here, they need to create this infrastructure to install. So they deforestate, they begin to deforestate all this area for this thousand of, and also the mining of iron arrived in this area. What happened was all the communities with, can you see here in yellow, those little points? It was all the community we could be visiting to listen people about this aeolic towers arrive in this area. And what they say was they didn't know about this development project for energy transition. And when these towers arrived, the jaguar lose their habitat. So the jaguar begins to attack the communities because they don't have more their natural habitat. You can change it, Lindsay, the slide, please. And then during 3 years visiting this area, we could map the conflict lesson communities. In green, it was the actors that we listen about the arrival of this project and how they pointed that the problem was creating problem in this area. So the national park for them was a problem because they lose the access to land. They could not have their animals no more. The mining and the renewable energy with wind towers was a problem because it impacted the jaguar, and the jaguar beginning to attack them more than historical common. And all of this was allowed by municipal, national, federal government, and transnational companies. So they blame a lot from government that give the permission to this model of development arrive in their communities. And they has really no power of decision. So they was not involved to biodiversity conservation decisions. They were not involved for development energy transition decisions. And for them, this is the picture of conflict relating their territory. Then you can change the, please. So what we could see is that this global need of sustainability agendas can, yes, overlap local problems and make territorial conflicts, even if it is for transition energy and biodiversity conservation. It has been implemented without meaningful participation of communities. The benefits of this energy transition is not arriving for them. They have no participation of economic production of money, that they are just make extraction of this richness. Traditional communities are not involved in this decision, and the transition can be just if they have transparent dialogue, recognition, and consider local knowledge and share the benefits. It's not happening in local in this case study that we were studying. And I think it's this that I would like to share with you. Sorry, my English, there is a long time that I don't speak English, so I hope I could be transmit you some message.
Yeah, Amanda, that was great, and I think really sets the tone well um, for yeah, thinking about exactly all of those sort of grappling with environmental and sort of community conflicts or conflicts and tensions and just nuances across the landscape. Um, so I so Unai Pascual, who many of you probably know, former SSC member, now current GLP fellow, um, is a part of the project and actually was also sort of a part of the project that Amanda just presented on bridging values. He wasn't able to join us today, but I did want to just give a quick highlight to his project, because his new project, Just Biosolar, because it, as Amanda was sort of giving us that sense of that community and landscape in Brazil, that was one of the impetuses that Unai had sort of taken, and then and the project team had taken and gone forward with this Just Biosolar project, which is looking more specifically and more directly at this sort of green energy transitions, and particularly sort of in Europe, and then sort of the effects around the world as well. So they're looking at sort of the trade-offs between climate change mitigation, biodiversity conservation, including diverse values, how to bring diverse values, as Amanda and Monica both sort of mentioned, this sort of biocultural implications and justice implications. And they're doing this in a multi-scalar approach. I wanted to just give a little shout out to the case studies that Unai and that team are working on, because it spans across many countries in Europe, particularly looking at photovoltaic and agrivoltaic installations. And then also, they have some partners that are looking at more the mining sites for these photovoltaic panels, both in Sweden and Colombia, and some of the sort of traditional lands that are being disrupted for the mining. And so I think this is, just a sort of going to be a really exciting sort of area of bringing together, again, a lot of these themes that you've heard from both Monica and Amanda, and now sort of bringing it into also Europe context, as they kind of look through their main research questions on, the guiding, not only the impacts on biodiversity and sort of justice implications, but also sort of the guiding principles and practices that can be adopted to sort of address how to do these projects better in the future, and think about these sort of open discourses and the actor constellations and power dynamics involved in this whole sort of energy landscape. So so I wanted to give a quick highlight to Unai. Like I said, we're gonna at the end have a moment to think about where this leads. So hopefully, if you're hearing some good connection points and ways to to potentially connect with some of these projects, that's what we want to capture at the end. So but with that, I want to turn to another project. So this is Caroline, and Caroline, are you on the line right now? I saw you come in. So
Yes.
okay, great. So so you have about 5 minutes if you can. Thanks.
Okay. Hi. Thanks a lot, Bar. Actually, it's a pleasure to be here today, and thank you for inviting me for this section. So just to introduce myself quickly, my name is Caroline Salomão. My background, I'm environmental engineering and business administrator, and I did my master more in modeling and analysis of environmental system and my PhD in water resources. So currently I'm working as a scientist and project manager at Tuning Institute in Hamburg. But today I will not talk about the project that I currently involved, but I will talk about the project that I involved during my doctorate. I work it, unfortunately, it's not appear. Maybe I did the last change in a short time, but I was one of the PhD researchers in a big project called Water Security for Home in Colombia. And this project was a partnership between Humboldt University and Javeriana, Universidad Javeriana in Colombia, and Federal University of Minas Gerais in Brazil. And the focus of the project was analyze the inequalities around multi-proposal reservoirs in Colombia. And my presentation will focus on two papers that I developed during this period and with different professors and colleagues that are also in this project. And maybe do it to the time and do it to the focus of the section. I will focus more in the second, but just to contextualize, my focus during the project was more analyze the drivers of change in land system, especially in social ecological systems that are more focused in agriculture production in Colombia. And in the project, we had four cases of study, but I decided to focus in just two cases. And these two areas are really focused in the coffee production, more in the south of Colombia. And the another one more in palm oil production, more in the north. But the four cases and the two cases that I focused was in the Colombia Andes. And the first paper that we wrote were more focused on the expansion of these hydropower dams, because the two cases had different timelines in terms of the construction and the operation of the hydropower dams, and also different dynamics in terms of land use, as I explained before. But also I focus more remote sensing and geoprocess techniques, and to analyze and see this change through the time. And the two cases was a result of my first paper. And the second one, I went deeper in the social ecological system and the topics about adaptation and transformations of socio-ecological system, resilience, and I use more social science approach. I use face-to-face interviews to understand the drivers of change, but now through the lenses of the stakeholders, the farmers on the field. And the next slide. Just to give an overview of the result of this first paper. Here you have the first column, the result for the first case, hydropower case, called Betania and Kimbo, the reservoir. And here is an area more. The first line is the Hidrosogamoso reservoir, more in the north, and this area was more occupied by palm oil and in pasture before the dam arrived. But we saw a kind of transformation and how the dam occupy, but also still with the area for palm oil is still together with the reservoir. And there are other study area in the second line was Betania and Kimbo, the name of the reservoir. But in this case, the whole area of the reservoir was taken by the flooded area for the reservoir. So many areas with coffee, cocoa, and rice production was replaced by the reservoir. So the dynamic was different if you compare the two cases. But I will jump it to my and just to give a disclaimer here, we decide to use Landsat time series. We have more more finer resolution, if you use if you use Sentinel, if you use different products. But Colombia has a really challenge, has a certain areas in Africa, for example, due to the shadows, due to the availability of the images. So we decide to be more consistently in terms of the timeline, since we like it to analyze a huge timeline after the construction, during the construction and operational phase, and after the operational phase, to see the impact. And Colombia doesn't have your own maps. The government doesn't have your own apps with this consistently in terms of timeline. So we decide to generate the maps, and we have always this question about the importance of have local maps, regional maps, versus we have global maps or country maps. So this is the reason that we build in the project our own. I build in the project our own maps, and with different classes, because we'd like to analyze the specific agriculture classes. And the next slide, my last one.
Okay, great. I was like, yeah, that's awesome. Thanks, Caroline.
Yeah, and here I just write through the interviews. Was more than 8 semi-structured interviews, analyze the chains and the drivers in chains, and the drivers in land and water use for agriculture production during this period, pre-then and post-then. And we try to see the adaptations and transformations, and we saw a lot of different drivers of change. Was not possible to separate the dam from the impacts that the farmers receive. For example, was due to the market change, due to the market's requirements regarding the sustainable production certifications, and also the increase in costs due to the fertilizers. Was difficult to separate the effects due to the construction of the dam, but was really clear how the improvements of the impact assessment instruments was really necessary to have a real overview of the farmers. So this is the big message. And of course, we saw also the downstream and the smallholders farmers was the most affected, especially due to the operational phase. We have a lot of literature exploring the construction, but we don't have a lot of literature exploring the post phase, the operational phase. So and was also a kind of change in terms of change, because the first came the hydropower, then came, for example, the impact due to climate phenomena that collaborate again with the impact that the communities suffer. And but also was difficult, as I explained, separate the impact due to the underlying drivers. But that's it, and sorry for the time.
No,
And
thanks.
just,
No, Caroline, that was awesome, because I think this is such a great bringing together of not just the spatial and analytical components of like using the satellite images, but then also going deep into the semi-structured interviews and thinking about like how this is actually reflected on the ground. I think is like such an important sort of component of how we're starting to try to tease out how to assess these sorts of renewable energy projects. So this is, what a wealth of
Thanks a lot.
knowledge here.
Thanks
Thank you. I think Karen is here, but I'm just going to give a quick overview of Karen Lopez Olmedo and their team, mostly because I think, the work is amazing, and I think there's some really interesting parallels between this work and some work that I actually conducted with another colleague of mine, Megan Egler, on sort of solar sites within the United States and Canada. And in these cases, maybe there's a little bit more of a positive community spin, or a lot of, like I said, there's nuances and tensions across the landscape throughout all of sort of the energy landscape. But in this study that Karen and team were conducting on farmers in Pennsylvania, They did a media sentiment analysis, which is another sort of interesting way at getting at, sort of understanding, like how people are feeling and how these sorts of energy projects are reflected in the media. And they found actually a really positive response within the agrivoltaic technology in Pennsylvania. They followed that up with a survey. They had 90 responses of sort of farmers who are either interested in or already incorporating solar panels on their farm. And they did a sort of follow-up in-depth interviews with farmers with, this piece, with the sort of resounding consensus that the potential environmental, social, and economic benefits of agrivoltaics was actually really, really positive, though with some costs, to note. And Karen actually sent me an amazing slideshow of her slides as well. I want to follow this up in the discussion as like how we can like have a compendium of resources here. I didn't quite get to integrate them into this presentation, but I think this is a really kind of an interesting seed within the landscape of like one place where work is coming out that a lot of communities are really responding really positively and really wanting these sorts of technologies, you know, in their spaces and on their landscapes. And sort of similarly, or sort of in thinking about this and thinking about how we can assess, um, or different ways of sort of assessing how these projects are sort of being received and what their implications are, particularly related to sort of community and communal lands and justice. This was a study that I was a part of with led by Megan Egler, who we did a case comparison of renewable energy projects that were specifically being used as solar panels that were being placed on old fossil fuel sites. So with a specific idea of like these are hybrid technologies. They're technologies that are bridging us from a fossil fuel past to a renewable energy future. And you can see from both of these studies, one in Kentucky, the Martin County Solar Project, and one in Alberta, Renewwell, these sort of like highlights of, oil wells that end well, from black gold to golden opportunity, this idea of like the energy transition is just going to be this, great green transition and benefits to communities that were otherwise maybe negatively impacted by fossil fuel infrastructure and now are getting the economic and environmental benefits of renewable energy. Now, what we did in this paper was actually try to assess those sort of claims or like those, what was being sort of posed as those narratives for these two projects in particular. And we took a look at it from three different, lenses along the justice sort of lens. So we looked at recognition justice. So actually looking at like, are these projects actually recognizing and addressing past harms, and how procedural justice, like looking at like, did these projects actually meaningfully engage the communities that they are, posing that they're, serving and doing a great, good for. And then distributional justice, looking at the actual resources and economic control, like who are the corporations that own these technologies that are, benefiting economically. And not to get too into the weeds, but one of these projects, Kentucky, did not score very well on any of these cases of justice, and in fact had a lot of community sort of backlash and like people that were really upset about this project. Whereas actually in Alberta there was much more engagement, and it was actually benefiting the farmers that wanted these technologies on their oil wells, and it was a much more sort of distributed and like community consensus project. But yeah, just to kind of highlight one way that we were trying to think about how we can start to assess these projects on the ground level. And with the idea of assessment, this is where I want to sort of think about, okay, for assessing projects and trying to think about how we can maybe think about where energy can be, where these sort of energy technologies can be. I want to turn it over to Ash from the Nature Conservancy to talk about, their work and tools.
Thanks, Bar.
Yeah.
Nice to meet everyone here. My name is Ash. I'm really grateful to be in this space and to hear about all the projects so far and like just the diverse range of approaches and also like the scope of work that's happening. My background is as an interdisciplinary ecologist. So my PhD was actually in distribution and drivers of diversity, vertebrate diversity, for scavengers in South Asia, and also the ecosystem service angle and the human dimensions of conservation. So like the farmer interactions with the wildlife and the ecosystem services that they provide. So that's sort of just like my training, my formal training and background. A lot of that work was done like at different spatial scales, different ecosystem types. But it's also how I got involved in the human dimensions work. And now I sit in the Nature Conservancy's clean energy transition work. And specifically, a lot of this work, my work, is very social and ecological focused and understanding how we can integrate those components into the sort of evidence-based guidance and collaborations that we do. And this often happens at a national scale or at like larger project scales globally. So my slide here is just a sort of quick overview of the approach that TNC uses at a global scale towards its renewable energy strategies. So it's a figure from one of our papers that focused on the approach and the build out scenarios in Europe for Europe's energy transition. So at a continental scale, Europe has this directive around renewable acceleration areas and sort of funneling a lot of spatial data into finding areas that can then kind of have a fast transition. And of course, that can be pretty alarming depending on how this like works, right? If it's such a top-down approach and the sort of spatial scale at what that, like the implications of that, that's sort of where we are in between there. So there's like this gap between scale that we're doing our best to sort of see how we can help with evidence to sort of funnel or help guide renewable energy planning towards lower conflict areas or avoiding high value areas using proxy data. So in this funnel diagram, it sort of just shows this like 4-step approach, or we call it the smart siting methodology. And that integrates 3 different but often siloed dimensions. And I think a lot of people here actually it's already kind of integrated into many people's work. And that's a great thing, which kind of puts together energy potential and technical feasibility with conservation assets. And importantly, the social dimension or the social aspects via hierarchical filters. So in this example, the output happens to be renewable acceleration areas, but that should ensure that beyond the energy yield, it should be also considering environmental and social elements. However, there are many different ways that this data could be put together, and I will state that like the way TNC works, while we collaborate with different countries and different partners, it's not always renewable acceleration areas. So it might look like a web tool that has, ranked parcels. It might look like a map viewer that has a bunch of data sets that can then be used in different ways to like kind of use the mitigation hierarchy to then guide how developers, how communities might want to use that information. Yeah, I can move to the next slide, Lauren. And so I don't have too much time today, and I don't want to like get too into the weeds for all the work, but I'm going to be presenting 2 examples very briefly. The first is some of our work in India. So in India, the Nature Conservancy India has partnered with 3 organizations, the Vasudha Foundation, CSTEP, and the Foundation for Ecological Security. And the purpose there was to create a spatial tool that could then be used by stakeholders, main decision makers, the main players in this field, to more responsibly cite some of the renewable energy that's coming up in the country. So India has very ambitious renewable energy goals, and there is a pretty large land footprint, especially in the case of solar. And so what this work does is basically there's data from a collaboration between Microsoft, Planet, and TNC called Global Renewables Watch, where they use remote sensing information to predict, well, first to have a layer of where infrastructure exists for solar and wind, as well as predictions of where it can be. That data is integrated with several environmental data sets around habitat, corridor information, land use types. And then also we have a social data set, and that's something that I am more closely working with. And that social data set uses census data. It's relatively old data, but it is valuable in terms of like the scale at which it is and the kind of dimension that it focuses on, and I'll talk a little bit about that. But essentially, this tool is online, and I invite everyone to go and take a look if you're interested. But there are 3 modules to the tool. So there's an awareness module that looks at like extent of constraints, so environmental constraints, development potential, and where the low conflict areas are. There's an assessment module, and so that's where the environmental data and the social data lives. And it summarizes potential conflict for, you can put in a boundary, like you can draw a boundary, or you can put in polygons. And so right now the tool is live for 9 states in India. However, we do have data for all the states, and we're currently working on updating the tool for that. And then finally, there's a citing module. So the citing module is kind of more developer and decision maker focused to some. So it identifies land parcels. So it ranks land parcels, but that's based on the development potential data that we have, but taking into account the suitability, right? So the environmental conflicts that we're flagging, as well as the social conflicts, so that developers, if they're looking at a space or at an area, can go into that in a more informed manner and know. And a big part of this is kind of initial preliminary screening. So this is not meant to be go areas or no-go areas, but rather educational and informational, so that they know where community engagement or environmental impact assessments have to be done. Often the governance framework is a part of this. So, in some countries, it really ranges in how much they have to do. And so in India, we are also working with the government and at the state level, because that varies from place to place. And then I just want to really briefly touch, because at the GLP conference, I think in Oaxaca, I presented a more in-depth look into the social values data that is in this tool. And I'll just mention really quickly, because for interest and for the people that are at this presentation, that data focuses on common lands. And I just really want to touch on why we chose common lands for this tool. So common lands is central to India and to South Asia in general. So South Asia is home to nearly 1/4 of the world's population, and just over 4% of the global land area. And particularly in India, this pressure is well represented through common land. So common lands makes up about 1/4 of the country's land area, but it's important to meet the subsistence and livelihood needs of a lot of people. So estimated about 350 million people will depend on common lands for their resources. So importantly, this is some of the land, because it's often its land governance and its land tenure is not always clear. And these are usually publicly managed and traditionally managed lands. These can sometimes be some of the first lands that's given up by the government as like go-to for developers. And so it's technically under government jurisdiction. So that's sort of why we focused on this angle, and we collaborated with Foundation for Ecological Security, because that's their focus. And so that's where we used the census data for 12 indicators that are relevant after scoping with community members to understand what might be the most important aspects that we can integrate here. So there's a lot in here, and I'm happy to chat otherwise, like at another time, but this is live, and I really invite people to go on and look at it. And then really quickly, I can go to the next slide to talk about our work in Portugal. So in Portugal, this is a more recent project that we had. This was a national scale project, and this one we've worked less closely with the government, because a lot of the acceleration area work is not, I think it's only starting now. I mean, it's been going on for a while, but there hasn't been like a formal process that we could get involved with just yet. So a lot of this work was with LNEG and APREN. And what we were doing here, the main objective was to help create data sets that will then be useful to identify low conflict areas and demonstrate like the strong technical feasibility for wind and solar development that exists in Portugal to meet those 2030 climate goals, while also being policy aligned, practical, and following the sort of low conflict or smart siting sort of approach. So what we're trying to do here is support the national spatial planning work of Portugal, but we want to go beyond low conflict lands. So we want to identify high development potential areas that might require mitigation measures. And so how would that look? Like, what are the considerations that have to be made? So we put together low conflict, moderate conflict, high conflict for biodiversity and for social, so that can then be, used in an informed manner. So the mitigation framework is really important in this work. And so this is informing strategies for avoidance, mitigation, restoration, And so, yeah, really quickly, I'll just say that for the development potential, it's similar to the India approach. For the conservation values, we have fine filter, coarse filter. And then for social values, I created a viewshed data set like to look at visibility sensitivity. So a lot of that focused on landscape values. There's a lot of data here. We also had a participatory mapping component. I'm happy to talk about it offline another time. But yeah, there's a report for this online as well if people are interested in reading about it.
Yeah, Ash, thank you so much. And yes, okay, so much to say. We have one more presenter, and then I also just wanted to mention, the goal of this session kind of coming out of it is that we are going to have a second follow-up discussion session where we can actually all sort of open it up and have a more informal discussion. So do put your name in the chat and or email if you want to be a part of that, of like finding a time to like have a really meaty discussion session around all of these topics. But I do want to give, so we're going to go a little bit over, but hopefully you can all stay because we have another sort of really awesome presenter looking at the expansion of photovoltaic systems in Switzerland. And then I'll give just a very quick update at the end about like some of where we, and from my wearing my GLP science policy hat, there's a lot of opportunities sort of here to connect and across, collaborate across the GLP membership and work towards some really cool goals that are sort of ongoing and with our partners in the community. So hopefully you can stick around, but Jonas, go ahead, please.
Yeah, thanks a lot, Bar. My name is Jonas Schwab, and I'm based in Hanover in Germany. But before that, I was actually living in Switzerland and doing research in Switzerland for more than 10 years. And here you can see this solar park that has been installed and is still under construction close to Davos Klosters in Switzerland. Maybe some of you know the place because the World Economic Forum also takes place there. And the expansion of these solar parks in Switzerland is actually a quite recent phenomenon. So it started more or less in 2023, or actually that these solar parks were planned, and is now now they are being installed, but there's still not that many. It's between 2023 and 2024, there were 50 or 60 being planned. And actually for these solar parks that were being planned in Switzerland, we have some nice information. So we know whether the local population, whether the municipalities approved the installation or whether they rejected the installation. And so, if you can go to the next slide. So with this data, a colleague of mine in Bern, Isabel Stadelmann-Steffen, tried to see if she could predict how the municipalities, how the local population would vote when they can decide on these projects. And what she found was that actually, maybe not that surprising, if the owners of the projects of these the developers, let's say, that planned these projects, if they were far away from the places where these projects should develop, it was more likely that the local population would reject the project. And this happens quite often in Switzerland, that it's bigger energy companies that actually then plan a solar park in the Alps within these smaller communities, and then it often gets rejected. Another interesting thing that you found was that if they were big, generally, then it was more likely that they were rejected. So if they covered a big area. And one last interesting thing was that it depended also on the vote, how people in the municipalities voted. So here you can see a picture where people are standing there and they are raising their hands. And actually, this is still sometimes happening in Switzerland. And this is a public vote. Everybody can see whether you wanted the solar park to be in this municipality or not. And actually, if it was a public vote, it was less likely that these solar parks were accepted in the municipality. And one hypothesis of Isabel is that it could be because, well, generally, these solar parks are considered as something that is helpful for Switzerland, of course, when mitigating climate change. But on the other hand, there are a lot of local concerns, and her hypothesis is that people are maybe sometimes afraid to show these concerns when it's a public vote. Yeah, and if you can go to the next slide. And so we followed up on this work and looked at it from a bit of a different angle. So what we did was that we used information that was produced in a lot of different stakeholder workshops in Switzerland with the involvement of lots of stakeholders and experts that said that came up with criteria that should be considered when these solar parks are being built. So with spatial criteria that would be important. And they can be roughly divided into economic, biodiversity, and landscape criteria. And then we also checked whether we could see something in these criteria that would systematically relate to the decisions of the municipalities. So whether they would approve or reject the project. And we can hardly see anything. So the only thing that seemed to be relevant was the intensity of land use. So whether there was a lot of infrastructure, for example. So if there were a lot of skiing slopes, then and already a lot of infrastructure for humans, let's say, then it was more likely that the municipality would approve and that it will not be rejected. Yeah, and I think what was really interesting and surprising to us is that not many of these criteria that according to the experts and the stakeholders should be taken into account were actually taken into account in these decisions. And I think it really shows that well, I guess it emphasizes also what Ash showed, so that these tools for that support the siting of the solar parks are really relevant, and that we need yeah, maybe also some spatial policies that support these local decisions in a better way. Yeah, and that was already the little excursion to Switzerland. Thanks.
Oh, thank you so much, Jonas. And yeah, I think that was a great, like arc through not just like then once they're cited, it's like, or like in the citing tools, you can think about like where to cite these energy systems. But I loved how you added in that like were projects rejected and why not, and like what, like what the community kind of like decision making like factors that go into whether or not things are rejected or not. So yeah, thank you. And, to everybody here, again, thanks all for joining and for sticking around for this, a little bit longer, like last session of the week of Land System Science. We had, like I said, just an amazing suite of experts. And as we saw in the chat, there's other experts here in the audience, you all like, and definitely we're going to get in touch and have this discussion session after. So yeah, just calling out the Miro board, of course, if you want to put things there. Thank you to all of our presenters. I'm going to skip over this for a quick second and just say for our next steps in terms of staying engaged. So yeah, Sonia and I have been scheming. We're going to have a much more sort of low-key but like open discussion time with all of the presenters, with any of you who want to join. So please drop your name and email in the chat, and then I'll be expanding that also in invitation to go out to broader GLP membership as well. Some things that I saw Anna brought this up in the chat. So some things that we were thinking about were like, do we want to think about making a GLP working group? There's a lot of opportunities. Something I didn't get to touch on is the GLP has been involved in this Knowledge Alliance on Land sort of partnership, a lot of collaborative work between organizations within, primarily sort of led right now from the International Land Coalition. Landesa and Land Matrix have been a huge part of this work, and then GLP as well. And actually a lot of the presenters today have been contributing case studies to this sort of ongoing work on energy transitions within this. And there's a lot of opportunities, I'd say, to connect and work collectively within and beyond GLP. with, again, my GLP science policy lead hat on, we've been developing and workshopping a series of science for action sort of briefs. And, so this is an idea that maybe we think about how we can synthesize some of this amazing work that's coming out of GLP. And then Sonia and I have talked a lot about sort of collective resources, sharing resources and expertise, maybe a library of presentations, a compendium of sorts. So these are just some open seeds that we'll talk about more in our discussion section. And also, if any of these resonate, or if you have anything else to add into the discussion pot, toss it, please. Feel free to put it in the chat. Or, Friday afternoon, I'm happy to hang here, so I can stick around. I don't want to, hold anybody over time too much here, but I'll be here, so happy to open the mic and let people sort of filter out as they want, or stay in and discuss some of these pieces. And like I said, everybody will get a little follow-up with the recording, but then also with this idea of we would love to carry this over into a discussion that we can all participate in. So yeah, I will stop there for now. And I'm excited to also, side note, excited to share more about the Knowledge Alliance on Land, because there's a lot of momentum and energy on that project too. But we'll save that for the open discussion time, or if folks want to stick around and hear a little bit more informally now. But yeah, for now, I will close the session, say thank you to everybody. And yeah, and then we can stick around informally if there's anything folks want to chat about. So thank you. And thanks especially to all of our presenters. So thank you all.
Thanks, Bar, and thanks to all the presenters. So excellent.